When talking about center of mass, it's important to remember that the center of mass of a system of masses behaves as if all the mass is concentrated at the center of mass. That's one key thing. That's the justification of what we did in the past when we assumed that that all objects that we dealt with didn't have a shape and all the mass was concentrated in a point. We treated them like a point. That's the case. So the center of mass of a system behaves as if all the mass is concentrated at the center of the mass. Like that donut, it is treated like all the mass is in the middle of the donut, even though we don't have any mass in that particular point. When we think of the center of mass, the object is going to move as if all the mass is concentrated in that point, the center of mass, and it's going to move as if we have a point particle, just one point. Okay, to illustrate that, let's look at some video. Okay, this particular case. Okay, they are going to throw objects in a brightly lit room. In this case, it looks like a tennis racket, and you see it as it moved. It actually kind of spun around. It spins about the center of mass. Okay, let me repeat that. Like that's what we have discussed before. Naturally, an object is going to have the tendency to spin, to rotate about its center of mass. And this is what happens. Okay, and that's what you see. Now they toss another object, same phenomenon. Toss another object from the other side, and same phenomenon. Now, what they are doing now is put in a light source in the object and darken the room. Put a light source at the center of mass of the object and darken the room. And they are tossing the same objects. See there? It looks like just one point. You don't see the rotation anymore. It does not matter if it is the racket or the other objects. All of them move like they are one point. Okay, that's where the center of the object is. Look at the motion. It looks like just one point. The other important point, the velocity of the center of mass is unaffected if we don't have any external forces on the system. The center of mass is going to act like either continue moving at a constant velocity or remain at rest if the external force is zero. Let's show another example to illustrate that, another video. So what we have here, two carts on wheels. To reduce the external forces, when using wheels, friction is not going to play much of a role, and our center of mass is going to be marked by this pole here, by this pole in the middle here, and this yellow mark. So we are going to have two gentlemen sit on each of the carts. And they are going to engage in a sort of tug of war. And you notice that since there are no external forces, the position of the center of mass is going to remain the same. So the velocity of the center of mass is unaffected if the external forces add up to zero.